I've often thought, you know, of all the things that I could have done, and I think that a lot of people probably go through the same phase in their life where they think they're fascinated with marine biology and, oh, I'm going to be a marine biologist, or I'm going to, I don't know, I bet there's a huge percentage of people, both boys and girls, that go through that phase. And our next speaker is someone who actually stuck with it and has reached the pinnacle of that profession, and he's here to share it with us. Dave Gallo.
Thanks, Julian. Thank you. I didn't stick with it. I did get a PhD, but I had an ADD before I had PhD. You know, between the two of them, ADD and PhD, I always think that one of them leads to very odd social behavior, and the other one you can take Adderall and things for. So it's usually one is curable. I'm just going to share some things with you from the world, that world, and mostly about how we perceive it. But you know, that image from space should have stopped us in our tracks, because we're not supposed to see that image of the Earth from space. I mean, that's something that's extremely unusual for any species to look back on its whole environment. And yet we've become very used to it. You know, we think we know that planet now. And what's the secret signal? Just this for the sake. If you take away the clouds, you see that most of the Earth is covered with ocean. And you hear that quite a bit in schools still and in the media, that 70% of the Earth is covered by ocean. But what does that mean? I mean, it just rolls off our tongues, and its average depth's about 2 miles. There it is, it's mostly blue. That, by the way, is the Pacific Ocean. And you hardly see any continents at all. So when you look at maps, you see a lot of continents, because sometimes they double. You'll see 2 South Americas and two Australias, because they're trying to fill up the map. They don't want to just have blue on the map. But that's what the Earth really looks like, mostly blue. Next, please. One of the problems we have about the ocean is that no one really cares about it, even though we say we do. You really don't. And this is from the New Yorker. I don't know why I don't care about the bottom of the ocean, but I don't. And next, please. And if you think about it, just this past 12 months, we had the earthquake in Japan. That's all about the bottom of the ocean. Next, please. The tsunami that came after that and the nuclear issues that followed that, all about the bottom of the ocean and the water above it. Okay, we were clueless about what to do, how to react to that. Next, please. This on the top is Deepwater Horizon from the Gulf of Mexico a little over a year ago, and on the bottom a mythical monster called the Kraken that's attacking ships. And that was something else, because here we had a leaky pipe on the bottom of right in our backyard from the bottom of the ocean, about a mile down. We couldn't stop it. We couldn't stop the oil leaking out, yet we were driving robots around the Mars at the same time, so there was something really wrong. I mean, this was really an incredible Keystone Cops response to a simple disaster in our own backyards. Why? Because it was at the bottom of the sea, and we don't know much, again, about the environment at the bottom of the sea. Next, please. And I'm going to talk a little bit more about this later, but this plane, about 2 years ago, dropped out of the sky over the middle of the Atlantic Ocean. It was on its way from Rio to Paris, France, and right in the middle of the Atlantic between South America and Africa. It took 2 years to find this, and we just found it about a month ago. Next, please. Okay, so there's an image of the world. It's mostly artistic. It's not really, it's based on scientific data, and yes, we've got maps with real scientific data, but I like this because it shows one thing really well. In the middle of the ocean, you see there's this gray thing that wiggles around the middle of the ocean. If you make this a sphere, it looks like the seams of a baseball. That's a mountain range, and it's not just a mountain range, it's the greatest mountain range on Earth. I mean, it dwarfs the Alps, it dwarfs the Rockies. It's 50,000 miles long. It's got thousands of peaks, higher than any peaks on land. It's got thousands of valleys, many, many times wider and deeper than the Grand Canyon, 1,000 times longer than the Grand Canyon. It's got underwater rivers, it's got underwater lakes, it's got underwater waterfalls, it's got more life on top of that mountain range in this valley that runs along the top of it than we have in our tropical rainforest, okay? Now, all that stuff I just mentioned, we find when we explore the ocean, but we've only explored about 4% of what's out there. So on this planet, that planet we call home, we've really only explored about 4% of what's out there. And the stuff we see is always surprising, sometimes startling, and sometimes it's really revolutionary. So let's go next, please. I want to show you, just give you a couple of images. We see the water here in the front. There's a little puddle of water. This is from the Institute for Exploration and NOAA, government agency. And you see water down here in the front and a little beach. Next, please. Next. And there's a closer look up with the lights shining on the water, so a nighttime view. And the next one, you'll see some ripples in the water. That water you're looking at is on the bottom of the Gulf of Mexico. So where you're sitting, where I am now, we're looking out the window of a submarine at a body of water under the ocean, okay? That's a small pool, but those pools can be lakes, they can be rivers, and in the next slide, I believe, there's a river that runs right along the seafloor right there. So this whole concept of rivers, lakes, waterfalls, something we never thought could happen. We always thought of the ocean as a big blue fishbowl, you know, and then now we're finding out there's all these really amazing things. In fact, next slide, please. The tallest waterfall on Earth, we think of it as an Angel Falls in Venezuela. Okay, it's about, I think it's about a half a mile up and down. Well, there's a waterfall off the west side of Iceland, way up there between Iceland and Greenland. That's about 5 times higher than Angel Falls, greatest waterfall on the planet at the bottom of the sea. The other thing about the ocean is, so that's the exploration part. The interesting part is it's the air we breathe. About every other breath of air that you take, every breath you take, you can owe to the ocean, because the oceans are the lungs of the planet, air we breathe. The food we eat, almost all food somehow ties right back into the ocean, whether it's fish or not, or whether it's agriculture, it ties into the ocean. And the water we drink, about 90-some-odd% of the rainfall on the planet, really critical to us, comes out of the ocean. Air we breathe, food we eat, water we drink, and yet it's coming out of this body of stuff on the earth that we've hardly explored at all. Okay, so that's the duality of it all. One is the excitement of exploring. The other one is, boy, we really need to know what's going on out there. Next, please. Bad news. 1912. I want to talk a little bit about this because it's not so much about Titanic as it is about the technology. But Titanic, as you may remember, was coming across the Atlantic Ocean, hit an iceberg, down it went. And for the first time ever, next please, we went out there. This is a picture of Titanic leaving the dock. Next one is the last picture of Titanic ever taken as it left Ireland, heading across the Atlantic Ocean. One of the greatest maritime disasters of all times. Jim Cameron made it really famous. Night to Remember was the first book about it. We went out, I co-led an expedition last September, August, September, with Premier Expeditions to, for the first time, really map the Titanic site. You know, we knew the ship, it's 100 years old next year, the shipwreck. We knew it's falling apart. I didn't want to get involved in Titanic, it's not my kind of thing, but man, you can't help it when you start to realize what happened on board the ship that night. All these incredible stories, all the best of humanity, all the worst of humanity. And the public interest is huge. You know, we can say we found a whole new species of life, or biogenesis at the bottom of the ocean. You get some interest. You say Titanic, you get global interest right away. It's pretty amazing. Next, please. I'm just going to show you, these images haven't been released yet, so I can't share all of them with you. They're going to be released pretty soon. But this is a view that very few people have seen, and it's not the crispest view, but there's an instrument called a sonar. It's going from bottom to top, and on the right side of the screen, for the first time ever, we got the bow of Titanic up in the top, and the stern of Titanic. It's broken in 2 pieces down here on the bottom. We also zoomed in, so this is a very rough view of Titanic broken in 2. But we zoomed in and we were able to map that whole site with incredible accuracy. So everything in the debris field around Titanic, the hull, the stern, everything in between now we've got, both in sound and in video. And next, please. Just want to give you an idea what the video looks like. I think you have to click that to make it go. Uh-oh, let's see if we can go back again, try it. No good. Yeah, there we go. Yay. Okay. These haven't been released yet either. That's the bow of Titanic right there. And here's the deal with this. So there's where Jack was king of the world. In fact, I was with Jim Cameron last week looking at Jim Cameron, a great filmmaker, but an even better ocean engineer. The guy's just absolutely positively amazing. That's the crane on the front of Titanic. Now here's the deal with this. So you've got just a couple of people in a submarine enjoying this or exploring, or you've got a team of people on board a ship looking at this stuff in real time. There's some of the machinery. But there's no reason why, there really is no reason why you can't bring this to the masses all at the same time, whether it's a satellite link, which we've done in the past, or better yet, to build a virtual Titanic. And one of our goals is to build a virtual Titanic. To start with Titanic, there's other things we want to look at too, but Titanic's a great starting point because there's so much interest in it. Now, the scientific community doesn't have the tools to do this, not really. But you know what the video game community does? I know they can do this. I know the technologies exist to make this virtual Titanic. We've got all the information. and to get it online and let people explore it the same way we do. So we've got not only the hull and the stern and all the pieces of Titanic, but we've got, again, those tens of thousands of objects in the debris field. Each one of them tells a certain story. Okay, next, please. This is a picture that captured the public's imagination back in 1986, but it's drawn by an artist, Ken Marshall. He's amazing. He's absolutely amazing. Looks like the real deal, but you know, we could never do that back then. Only recently, in the past year or so, did we have the technology, and that's what you need to explore when you're 2 or 3 miles deep like here. You've got to have the right technology to be able to make that a real image. So you can not only see Titanic, but you can also see people, in this case it's with a submarine, Elvin, our submarine exploring Titanic. So it's doable now. Next, please. Just want to say a few words quickly about this. Again, I said this plane, Air France Flight 447, 2 years ago, dropped out of the sky on the way from Rio to Paris. 228 people on board, all missing over the Atlantic Ocean. Next, please. It was 5 days, there's the flight track. It was 5 days, and next, before they found the first bits of wreckage. So 5 days after the plane hit the water, they started finding floating bits of the wreckage. Next, there's the tail fin, that's a piece of a galley. Next again, a combination of bits of the plane and bodies. The real detective work here was, okay, where did this plane actually hit the water? Because in order to understand how that plane went down, the only information was in those black boxes. And those black boxes, the cockpit voice recorder and the data recorder, both now sat on top of that underwater mountain range that I talked about in the beginning. So you have a plane that disappeared over the mid-Atlantic. The pieces of it were now sitting 3 miles deep, scattered around this mountain range that's more rugged than the Alps. And we had to go there and try to find bits of that plane. In fact, find something the size of a shoebox without there's no light at all. So you've got to go explore that world. But the first thing is, you know, we were sure, because we had been working in that mountain range for 40 years, we were sure if given the chance we could find it, but we had to know which haystack to look for the bits of the needle in. And to do that, we had to understand where these things came from, where all these floating bits came from, which was not easy either. Next, please. That's the search area, and we spent 2 months up in that box up on top, because that's where the models took us, and that proved to be not good. But next, please. We used 3 of these torpedo-shaped vehicles, and again, this is the issue with exploring this planet, is it's one thing to go to space, cool to go to space, but you know, from here to Mars, it's about 1 atmosphere difference, that's it. And plus you can use radio communications. At the bottom of the ocean, we can't see our hand in front of our face. In space, you can see eternity. We can't use radio waves, they don't go through the ocean, we have to use sound. Pressure on the bottom of the ocean is thousands of atmospheres. So all these things that you have to deal with in space, they're tougher. It's actually tougher to deal with at the bottom of the ocean. These are brand new robots. And so we use 3 of these from one ship. Next, please. And this is basically what they do. They're autonomous vehicles. So we're at the age of robots now, where you just turn these vehicles loose from a ship. They go down to the bottom by themselves. 3 of them working together, and they're actually mapping the bottom of the sea. And they were great. And next, please. Once we were in the right haystack, that's what the plane actually looks like in sonar, which is not a lot, but the people on board the ship were talented enough to be able to recognize that as bits of an aircraft. Next. And then you can send the robots back with cameras. That was sonar, these are cameras, and that's a piece of an engine. Next, please. Landing gear, and then so we had known that we had found the plane, and it was shortly after that, next please, that another team recovered the flight recorders, and they were able to piece together that mystery. But it just makes me nuts, you know, that on our own planet, Deepwater Horizon, the Japanese tsunami, you can even say Titanic to some extent, because we just didn't know what was going on with that ship, Air France, this disaster, that every time these things come up, that we have to scramble around. It's like a Keystone Cops thing. It takes years to get all the pieces in the right place, or months at the very best. And so that's if there's a disaster, but there is another disaster, which is that we're killing the ocean, and if we kill the ocean, I swear to God, we're going to kill ourselves. You know, we're doing that. We're going to love the ocean to death. And so we need to change our way, so we need to be out there doing the right thing. Next, please. I just want to don't want to leave you with a downer, so I want to show these again. These have been on TED Talks. This is some work that my friend Roger Hanlon does. He's at the Marine Biological Lab, and he studies cephalopods. And this shows you that not everything new is in deep water. Here's an octopus trying to hide from Roger. Dark skin, smooth skin. He's got to turn into that coral in the background. Looks for a place. And don't forget, he's got to know what he looks like to Roger curls up his arms to hide his arms, and disappears into the background. Next one is going to be some squid. When this species is aggressive, it turns white. So the guy in the white is pretty aggressive. In the next frame, you're going to see a female on the right, a male on the left, and he's smart enough that he splits his skin color, so she only sees Mr. Nice Guy. and he's on the squid on the outside, he's saying, "Stay away, I'm Mr. Aggressive." So, and the neat thing is that when they switch positions, you'll see here he starts out on the right, she's on the left, she's on the right. She starts moving over toward him. He says, "Oh no," slides to the back, and zip, Mr. Two-Faced. There he is. Ready, man? Hello, baby. I don't know if squids say that. I hope not. Cuttlefish. Cuttlefish are great. This is a giant Australian cuttlefish. He's studying Roger. Roger's studying him. But eventually he's going to try to hide in those rocks behind him. And there he goes. He changes his camouflage, but watch what he does with his tentacles. There he goes. Back to the background. So why do they do all this stuff? And Roger's at the forefront of understanding this whole camouflage thing. They have muscles in their skin. They have little ways to change the skin color to camouflage themselves. They've got to hide from predators like a barracuda. But in the next scene, there's going to be a big, smooth-skinned, light-colored octopus hiding. There's some algae and stuff here in the front, a white coral bottom. Here comes Roger. Okay, you'll see him in a minute. Right there. Yeah, that's his eye staring at Roger, and then he says, "Uh-oh, I'm out of here." Zip. And then Roger paddling after him. Now realizing that he's been caught, so he lands on the bottom and bluffs, makes a very big eye spot. But watch now, we're going to run backwards. Watch what this incredible animal can do, the cephalopod. Is that there's smooth skin, light skin. He's going to have to try to turn into that stuff on the left. And so little by little, and they do it like that. That's the amazing thing. There he goes. Okay, so, Yogi Berra said you can observe a lot just by watching. And and Yogi was right. So we're learning now when we go to the bottom of the ocean is that not to just go running around looking at all the highlights, but sometimes sit still and watch, and you learn an awful lot. There's a quote I want to leave you with by Marcel Proust, and it said, "The true voyage of exploration is not so much in seeking new landscapes, which we do, but it's in having new eyes." And I think with the new technology, being able to go 2, 3, 4, 5, in some cases 7 miles deep, we've got new eyes on the deep on most of this planet. And now that we've got the new eyes, we've got to start looking at this planet differently. Thanks very much. I always think that one of them leads to very odd social behavior, and the other one you can take Adderall and things for. So it's usually one is curable. I'm just going to share some things with you from the world, and mostly about how we perceive it. But that image from space should have stopped us in our tracks, because we're not supposed to see that image of the Earth from space. I mean, that's something that's extremely unusual for any species to look back on its whole environment. And yet we've become very used to it. We think we know that planet now. And what's the secret signal? Just this for the city. If you take away the clouds, you see that most of the Earth is covered with ocean. And you hear that quite a bit in schools still and in the media, that 70% of the Earth is covered by ocean. But what does that mean? I mean, it just rolls off our tongues, and the average depth's about 2 miles. There it is. It's mostly blue. That, by the way, is the Pacific Ocean. And you hardly see any continents at all. So when you look at maps, you see a lot of continents, because sometimes they double. You'll see 2 South Americas and two Australias, because they're trying to fill up the map. They don't want to just have blue on the map. But that's what the Earth really looks like, mostly blue. Next, please. One of the problems we have
I've often thought, of all the things that I could have done, and I think that a lot of people probably go through the same phase in their life where they think they're fascinated with marine biology and, I'm going to be a marine biologist, or I don't know, I bet there's a huge percentage of people, both boys and girls, that go through that phase. And our next speaker is someone who actually stuck with it and has reached the pinnacle of that profession, and he's here to share it with us. Dave Gallo.
Thanks, Julian. Thank you. I didn't stick with it. I did get a PhD, but I had an ADD before I had PhD. So, and between the two of them, ADD and PhD.